just a few snippets of C#, a few lines of code in a file. More interesting programs are usually made up of many files, so in this module let's up our game and focus on building a program from multiple files. And also, if you remember, there are a couple of lines in Hello World that we still didn't explain, because those lines are easier to understand once you know how to write programs with more than one file. In this module we'll cover these lines as well, so we're going to give one last look at Hello World. To show you how to use multiple files in C#, I wrote a new source file and we're going to use it in our project. It's a collection of small utility methods to do calculations on temperature and humidity. We'll write a program that uses these methods to compare what the weather feels like in different cities. I'll show you the content of this file in a moment. First, let's add it to the project. If you downloaded the examples for this training, you'll find it in this directory. It's this file here, weatherutilities.cs. I'll copy it and paste it into our project, right here in the Solution Explorer view. And now the file has been copied to the projects folder and it's part of the project. Let's see what it looks like. The file that we just added to the project contains a class with the same name as the file, Weather Utilities. That's a common practice, to have one class per file and the same name for the file and the class. It's certainly not mandatory, but it's a convenient default way to organize classes in files. And this class contains a few static methods. 1, 2, 4 methods. It's like a tiny library to do weather calculations. These methods build up on our earlier example. So we have the conversion from Fahrenheit to Celsius, you probably remember this one, and also the other way around, from Celsius to Fahrenheit. I also added this method that calculates something called the comfort index. It takes the temperature and humidity in percent, so a number from 0 to 100. And it returns an arbitrary index that essentially tells you how pleasant it is to do physical exercise at this temperature and humidity. Now, this idea of comfort is a vague concept. There are many possible ways to calculate comfort or perceived temperature and similar indexes. This formula that I found on the internet is just temperature plus humidity divided by 4. And the lower the index, the more comfortable it is to do physical exercise. It's certainly not a very reliable index, but it's simple and it kind of works for average temperatures and humidity, so it will do for now. And finally, we have this report method. It takes a string that's supposed to be the name of a place and its temperature and humidity, and prints a short report on the screen that shows the comfort index for this location. The plus operator applied to strings means concatenate these strings. So this is the string comfort index 4, followed by the name of the location, then a colon, then the comfort index calculated by this other method. Note that the comfort index is not a string, it's a float. But when we concatenate it to a string, C# converts it automatically from float to string. We know that C# is fussy about types, so it won't let us convert types implicitly. Unless it's a safe conversion we're talking about, and this one is a safe conversion. You can always convert a floating point number to a string without getting an error, so it's okay to have a float concatenated to a string, like here. So this is the class I came up with. I called it a library class. But speaking of that, I think I need to take a 2-minute digression about this concept of a library. I told you that I wrote this class that contains utility methods, and it's like a little library, right? And I copy-pasted this class in the project to use it from our program. Now, just to be clear, I don't want to give you the wrong message and encourage you to copy-paste code like that. In most cases, when you want to share functionality, like a library, you import the compiled library, not the source code of the library. Now, if you're used to compiled languages, you're thinking, of course. But if you're more used to interpreted languages, then it's worth spending a moment on this distinction. You remember that I told you earlier on that a C# project results in an assembly, a file, or sometimes a small bunch of files. So let's say that we have a project that delivers a Windows executable, and this project depends on a library, a DLL. Now, in general, you don't need the source code of the library, you just take the compiled library, a DLL file, put it into the project, and tell Visual Studio that the project depends on the DLL. Then, when you compile the project, Visual Studio will put both the executable and the DLL in the same directory, so that the executable can see the DLL and everything works at runtime. And there are other ways to make a DLL visible to a project in Visual Studio. You can put the DLL in a global area on your machine that's visible to any project. Or install the library from the internet using the NuGet package manager. All stuff that's outside the scope of this training, but one thing is common to all these cases. You don't copy-paste the source code. You generally share compiled code, not source code. The reason why I copy-pasted source code in our case is that we want to modify this code. And that's what we're going to do next. Here we are, back to our class of utility methods. Now, there are a few things that we can improve in this class before we go on and use it in our program. Small things, but they kinda add up. First, we could add comments. I did try to make this code self-explanatory, to use explicit names for variables like here and so on, but sometimes you just need a comment. For example, we said that this formula that calculates the comfort index is probably not the most accurate way to do it, so let's write a comment about that. If you type a double slash like this, everything that follows is a comment up to the end of the line. To be honest, this is the kind of comment that I end up regretting, because then I come back to my code after a while and I think, well, I should have fixed this code instead of commenting that it's not so great. But in this case, I plan to stop updating this code as soon as I finish this training, so maybe this time I'll get away with it, right? Another thing worth commenting is, when we call comfort index, we need to remember that higher indexes mean less comfort. That's not very intuitive, it's easy to get wrong, so let's write a comment about that. We've seen comments with a double slash, but there are other flavors of comments in C# as well. You can write a comment that spans multiple lines, delimited by a /* sequence in the beginning and a */ sequence in the end. And many people also add a few more asterisks to make it look nicer. And you can also write comments with advanced formatting, used to generate documentation for classes and methods and so on. But double slashes are probably the most common way to comment code. Besides comments, another small improvement we can make to this class is this method defines a variable and then returns it. But we don't need this intermediate variable. We can do the calculation and return the result straight away, like this. It's a little refactoring, as they call it, an internal change that doesn't change the behavior of the code, because this method returns the same result as before, but most programmers would find it a bit easier to read. Now, I'll show you something. These two methods also create temporary variables that we can remove. But this time, instead of doing it by hand, let's ask Visual Studio to do it for us. You can right-click on a variable and pick Quick Actions and Refactorings, and then Inline Temporary Variable. That means what we just did. Remove the variable and replace it with its value. See, Visual Studio shows us what it's going to do. This is the code we have now, and this is what we'll have after the refactoring. I click and bang, it's done. The variable has been inlined, and we can do the same thing here. Automated refactorings are super powerful. You have different refactorings available in different contexts, and some go way beyond inlining a variable. You can ask Visual Studio to bend and twist your code in so many ways. For example, this string concatenation. It's a bit of an eyesore with all these snippets of string joined together. C# has a more elegant way to combine strings called string interpolation. And if you open the refactoring menu, Visual Studio offers to convert this concatenation to an interpolated string. So let's do it. There. Look, this dollar prefix means that this is an interpolated string, which means it contains snippets of code in curly braces. So C# evaluates these snippets, it evaluates this variable and calls this method and embeds the results in the string. Nicer code, more readable, and we didn't have to write it by hand. Visual Studio did it for us. Okay, we improved this class. It's certainly not perfect yet. For example, one confusing detail is that comfort index takes the temperature in degrees Fahrenheit, while a report takes it in Celsius and then converts it to Fahrenheit before calling comfort index. So, this code is more convoluted than it could be, but let's stop here or else we'll never be done. This class is good enough, I guess. So now we have two files in our project. One contains the weather utilities class and the other contains the Hello World program from the previous module. Let's keep both files visible on the screen. I can drag this tab and drop it here. And now I can see both files at the same time. Now let's do this. Let's write a program that uses the report method to compare the comfort indexes for different cities. First, I'll go to our main method and delete this line that prints on the screen. And instead, let's call weatherutilities.report. The first argument to this method is supposed to be the name of a place, so I'll use the city where I live, Bologna. It's in northern Italy, about midway between Venice and Florence. And then we need a temperature and humidity for the report. So I looked up the temperature and humidity in Bologna for the month of May, as an example. The average temperature is nice, about 23 Celsius. That's 73 or 74 Fahrenheit. And it's a bit humid, about 65% humidity. Let me put a comment here with equivalent temperature in Fahrenheit, about 73. In case you're not used to Celsius. So we wrote the code that calls this method, but now Visual Studio is complaining about something. We have a red squiggle under the name of this class here. I can hover the cursor over the error and it says that this name isn't visible here. And the reason why the name of the class isn't visible is that when I wrote this class, I wrapped it in something called a namespace. Namespaces exist for a pragmatic reason, to avoid name clashes. Most projects are made up of many files and classes, and most also use libraries that add even more classes, so in a large project you can end up with thousands of classes, and it becomes quite likely that you'll have two classes with the same name. So, for example, if you're writing an application to manage an archive of documents, you might have a class named Document in your application, but maybe you also use a library to parse XML that also contains a class named Document, meaning an XML document in this case, so you have a clash. When you say document, C# doesn't know which of the two classes you're talking about. That's what namespaces are for. If two classes belong to different namespaces, then they can have the same name, because you can reference them by their qualified names, as they're called. That is, the namespace dot the name of the class, and then you don't get a name clash. Of course, you could still have a clash if you have two namespaces with the same name that contain classes with the same name. But that's unlikely to happen in practice, because developers tend to use the name of the project or the library as a namespace, like My Cool Archive in this case, or sometimes the name of the company they work for, like, say, Globomantics. And those names tend to be unique. And also you can have nested namespaces within namespaces, like globomantics.xml, for example, and those nested namespaces make a name clash even less likely. So that's the reason for namespaces. And when I wrote this class, I wrapped it in a namespace. And when Visual Studio generated the main program, it also put that program in its own namespace with the name of the project. You might wonder why Visual Studio created a namespace here. That looks unnecessary, because if you think about it, this class exists just to contain the main method, and the main method is going to be called by the .NET platform, not by us. We're never going to write my first program.main, for example. So why bother with having a namespace here if we're not even using the name of this class? Isn't that overkill? Thing is, first, it's considered bad form to have a class without a namespace. And second, if you have a class without a namespace, C# still assigns the class to a default, anonymous namespace. So in the end, you still have a namespace. So why not make it explicit at this point? Oh, by the way, while we're here, this class, let's rename it to something more appropriate, like check comfort. There. Now that we know about namespaces, so now this class belongs to this namespace, and this class belongs to this other namespace. If they were in the same namespace, they would see each other, but they're not, so we cannot just use the short name or whether utilities here, we have to use its fully qualified name, like this. And now the error went away. We have another error now, but the previous one about not being able to see the class, that one's fixed. On the other hand, in C# you use class names all the time, and you probably don't want to use qualified class names all the time. That would make the code really verbose. Instead, you can write something like this at the top of your file. This using directive means whenever I use this name, whether utilities in this file, what I actually mean is this qualified name. Essentially, this is an alias for this. And now I can use the alias instead of the fully qualified name. And we can make it even shorter. Instead of doing this for each class that we want to use, we can just say import all the classes from this namespace, like this. And now we can use the classes in my utilities by their short name. In this case, there is only one class in that namespace, and we can just use its name. So that's how you deal with namespaces in most cases. If you need even one class from a namespace, you just import the entire namespace, like this. Sometimes you might get a clash. Maybe you're using two classes with the same name from different namespaces in the same file. In that case, you get an error, and you can fix the issue by using the fully qualified names of the classes, maybe, or sometimes importing the specific classes you need instead of the entire namespaces like we're doing here, but in most cases you just import the entire namespace. One last thing about namespaces, what's this using system line doing here? What's this system namespace? The answer to this question is also a chance to check off an item that has been on our to-do list for a while, completing our knowledge of the Hello World. In the previous module, we checked Hello World line by line, except for a few lines. And now that you know about namespaces, we can go back to those few lines and finish the job. The class in Hello World, like any class, is wrapped in a namespace. When Visual Studio generated this code, it also gave a name to this namespace, the same name as the project. And then there is a using directive here. It's importing a namespace called system. System is the most useful namespace in all of .NET. .NET comes with many ready-to-use core libraries, and one of them is system. That contains the most important classes in a way, the ones that you want to have handy in most programs. And one of those classes is console, that gives you methods to input and output data from a program. So, if we want to call console.writeLine and print a string on the screen, we need to import the system namespace. That's where the console class lives. So, in the beginning, I told you that our first goal would be to understand Hello World, all of it, And we finally do. It took a while, didn't it? We could have explained it in 2 minutes, really, but only if we had skipped all the details. And now that we did take the time to explain them, I hope you agree that those details are important. In most languages, you see the code for Hello World and just move on, but in C#, going through Hello World, like we did, teaches you a lot, not just to print a line on the screen. That was the easy part. Yes, it's just Hello World, but now that you know how it works, you also know a lot of the building bricks of C#. So, we're finally going to say goodbye to Hello World, but I'll use this code to tell you one last thing. When we looked at this code in the beginning of the training, I said, look how much C# code we need to print something on the screen. However, you could write this program with less code, as long as you're running at least C#9, released in 2020. C#9 introduced a feature called top-level statements. That means that you can remove all the boilerplate from this program and just write it like this, without wrapping it in a main method and a class and the namespace. You import the system namespace to get the console class, you call console writeLine, and that's it. Now I hear you say, hey Paolo, are you kidding me? We spent like 2 modules talking about how much code we need to write Hello World, and now it turns out that almost all that code is unnecessary. Well, thing is, yes, C# has top-level statements, but those statements are actually syntactic sugar, as they say. They're just a nicer syntax for this code. But under the hood, C# still wraps the call to console writeLine in a main method, and the method in a class, and the class in a namespace. It's just that it generates all that stuff automatically under the hood. So, top-level statements are nice. They make a short program look better, but they don't change the essence of C# code. As soon as you start looking beyond a short program, you still need to know about classes and namespaces. So, when you're learning, it still makes sense to start from the old-fashioned, more verbose version of Hello World. And also, as I record this training, if you ask Visual Studio to generate Hello World, it doesn't use top-level statements and still generates all this boilerplate code. And that's why we kinda ignored top-level statements so far. And with that, no more Hello World, not ever again. Back to fixing compilation errors in this line. Earlier on we had an error here because we couldn't see this class. We fixed that error by importing this namespace. But now we have another error in this method. Why does it happen? I'll explain it with another example. Imagine a class that translates text from English to Japanese using an online translation service, maybe. So it has 2 methods called Japanese to English and English to Japanese that translate in the 2 directions. And maybe these methods have a lot of work to do before and after calling the online service. Maybe they convert symbols from a Japanese phonetic system to Latin letters or the other way around. And then let's say that at some point they both call another method named call_online service that does the lower level work of pushing the data to the online translation service and getting a response. So, 3 methods in this class, but only 2 of them are meant to be called from outside the class. They are public, part of the interface of the class. The 3rd method is only called from other methods inside the same class. It's private to the class, an implementation detail, and you want to hide it from the outside world. Coming back to our weather utilities class, there are 4 methods here, and most of them should be public. They exist to be called from outside the class. In C# there are 2 keywords, public and private, to decide what kind of accessibility a method should have. So you can say that a method is public like this. Actually, we have to do this because the default is that if we don't specify the accessibility of a method, then it's going to be private. So we should make these methods explicitly public. we can make an exception for the comfort index method. We don't need to call it from outside the class, only from inside the class, for now at least. So for the time being, we can keep it private, or even make it explicitly private for clarity, like this. If we ever need to call it from the outside, we can always change it to public later. And now we have 4 methods, but only 3 of them are part of the interface of this class. C# also has other access modifiers that are more specialized. For example, internal means that a method is visible to any class inside the same assembly, but not from other assemblies. And there are more, but you'll learn them when you need them. Public and private are the most common by far. And by the way, from the moment that we made the report method public, the error in our main program disappeared. We have no errors here anymore. We can finally run this program. Click on the Run button, and there we have it, the comfort index for the city of Bologna. We took it in small steps, but now we have a working program made of 2 separate classes. So this call reports the comfort index for the city of Bologna in May. Now let's say that together with a bunch of friends, we are looking for places to visit next May. Let me print a little title here. Where should we go next May? And we'd like to compare the comfort index for a few different cities, this city and others. Actually, I made a typo here. I wrote console with 2 L's, so this code does not compile. But this is a chance to show you how I can use Visual Studio's autocorrect to fix this issue. Here in the Quick Actions right button menu, Visual Studio is giving us a bunch of suggestions to fix this problem. Maybe you're talking about a new thing that is called console with 2 L's. Should I generate it for you? Or maybe you mean the console class with 1 L, and should I fix this spelling to reference that class? This last suggestion is what we want, so let's select it, and Visual Studio autocorrects the spelling of this class name for us. Okay, sorry for the digression. Getting back to our program, we'd like to compare the weather in this city and other cities. So I'll add a second call to the report method here. Note that we don't have to type the name of the class and the method letter by letter here. We can use autocomplete in Visual Studio like in any good modern development environment. So I just type the W here, select Weather Utilities from this drop-down list, type a dot, select the report method, and when I type the opening parenthesis, Visual Studio types the closing parenthesis automatically and shows me the definition of the report method so I can check the list of arguments. First, the location, let's say San Francisco. Then the temperature and humidity. I googled for it. In May, San Francisco has a temperature of about 65 Fahrenheit on average and average humidity of 73. However, let's not get confused, I almost made that mistake. This documentation here reminds us that this method wants the temperature in Celsius, not Fahrenheit. That convention worked well for my own city, because I found its average temperature on a European site. But for San Francisco I found the temperature in Fahrenheit when I googled, so let's convert it to Celsius, because we have conversion methods as well. So there, cool. And finally, another city we'd like to visit, let's say Denver, another US city. So I found the temperature in Fahrenheit is 77, and this code converts it to Celsius. And the average humidity of Denver in May, according to my note here, is 55%. So let's make this comparison and finally run our program, and well, apparently I'm living in the right place. The comfort index in Bologna is better, lower, than either SF or Denver. And to be honest, that makes me wonder, because, Bologna is a beautiful city and all, but the weather is kinda lousy. It tends to be humid and it always feels either too hot or too cold. It sure seems strange that Bologna wins against these cities that are kinda known for having good weather. It doesn't add up. I think that there is a bug in our code. And of course there is a bug, I did it on purpose, okay? I admit it. I prepared this twist very carefully, for good, because now we have a pretext to go bug hunting together in the next module.